Okay, this is lesson 4.3, line of best fit. So what is a line of best fit? Well, a line of best fit is a straight line drawn through data points to best represent a linear line relationship between two variables. You can also see this called as a trend line or a regression line. And you'll see that more often when you're using like Google Sheets to do analysis on the computer, or like Excel. The weaker the correlation, the more difficult it is to draw a line of best fit. There's also things called outliers. Outliers are points that lie outside or beyond the main cluster of data. And it may be caused by an inaccurate measurement or an anomaly in the data set. For example, someone that's unusually tall. If you had a 7-footer in your class and you were doing comparison of shoe size and height, well, that 7-footer would be, I don't know, 8 inches taller than the next tallest person. So that would be an outlier. The line of best fit should try to reflect all of the points in the data set, including outliers. One or more outliers will affect the path of a line of best fit. I'm going to show you how. So here we have 3 lines of best fit. We have graph A, where the line goes through the main cluster right in the middle. We have graph B, where the line goes right in the middle of the main cluster and these 2 dots that are outliers. And we have graph C, where the 2 outliers have pulled the line of best fit to the bottom of the main cluster. If you look, at the effect, this shows no effect from the outlier. Graph A is good. Oh, I should circle good there. Graph A is good. Graph B the outlier has too much influence. The line's pulled down too much by these outliers. This is not good. Graph C is perfect. The outliers have the appropriate effect. And that's good too. Now, when would you use graph A's line or graph B's line? You'd use graph A's line if you removed the outliers. If you don't want them to influence the line at all, that would be like you ignore them, and then there's a line of best fit of those points. Graph C is if you keep the outliers. You'd remove them if you knew that there was a mistake in the measurement, or maybe you got a bad answer to a question just because the person didn't understand the question, and you're confident that that data is flawed. You can just remove it. Otherwise, if it's not flawed and you just think that maybe you have that 7-footer in your class and he's a real person and you can't take him out of the data set because it's fair game that he's 7 feet, you keep him in and there's an influence on the line. Why do we draw lines of best fit? Well, we do it so we can make predictions. Line of best fit allows you to interpolate and extrapolate. If you're estimating among known values, that's interpolation. If you're predicting beyond known values, that is extrapolation. So what we're going to do next is we're going to, by hand, create a scatter plot. We're going to draw a line of best fit, and we're going to determine the equation of the line of best fit and make some predictions using our line. So let's try that next. Below are pre-exam term marks and exam marks for some students in grade 12 math class. Remember, x, y. The values on top are always your independents and the values on bottom are always your dependents. So that means we're going to have term marks as a percent, and we're going to have exam marks as a percent. And these are grade 12 math marks. We're going to graph the data, draw the line of best fit, and then come up with the equation of the line. Ooh. All right, let's graph our data first. Term mark 84, exam mark 80. We don't have a scale. Let's see what we got here. We got 1, 2, 3, 4, 5. Looks like about 10 by 10. Oh, it's 11 by 11. Either way, let's just go up by tens. So I'll 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm not going to write down every 10. I'll just go up by 20s and skip a line. 20, 40, 60, 80, 100. There we go. All right, term mark 84, exam mark 80. 85 would be in the middle, so just before that, and there we go. 76 and 72, that'd be 76 and 72. 70 and 68, 70's there, 70's there, 68. 95 and 96. Oh, wait a second. That was a bad one. 92 and 90. 92, 90. 61 and 58. 60, 58. 25 and 29. But we're all having a blast. 55 and 60. 51 and 53. 73 and 77. And 62 and 67. Whew. There we go. Now we got our dots. So once we've graphed all the data, we're going to draw our line of best fit. And remember, our line does not have to go through the origin. It has to go right through the middle of the data. So I've got some dots here. I'm going to put my ruler to go through the middle. And there we go. Extend it all the way across the graph. Make sure you hit that y-axis. That's going to be really important to come up with our equation. And there we go. So that's creating a scatter plot, drawing a line of best fit. Now, the fun part. Let's come up with the equation. This is going to take you back all the way to grade 10. That is the equation of a line. Y equals mx plus b. It has two parts, m and b. M, b. X and y are just the x and y variables. So x is term marks, y's are exam marks. We leave those in the equation. We do need to figure out what m and b are. We might remember, or we might forget, but m is slope, and b is y-intercept. The y-intercept's fairly easy to find. If we want the y-intercept, we look at where our line crosses the y-axis. So, it looks like we have to estimate because we're below 10. We're above 5. Let's call it 8. Our y-intercept is 8. So B is 8. So we can fill that in. Y equals mx plus 8. Slope. Slope's m. Still got to figure what m is. How do you find slope? Well, slope on a graph is rise over run. How do we find rise and run? Well, to do that, we need to pick 2 points on the line, so not actual data sets, but 2 spots on the line that we can read the coordinates off fairly easily. So if we look like we go through grid lines. Well, we know this one because we said it was 8. So let's try that point, and let's pick another point that we can read fairly easily. Looks like maybe right there. That looks like it's 80, 80. So we're going to go from here to there, and we're going to find a rise and run. So a rise and run is if you go straight across, that would be our run, and then straight up. How far did we go? Well, our run would be from 0 to 80. So our run is 80. Our rise would be from 8 to 80. So that's 72. We go up 72 because we're at 8 on the y-axis and we're going all the way up to 80. That's up 72. 80 minus 8 is 72. We can use those run and rise to find our slope. Rise divided by run, 72 over 80. And I'll get my calculator. 72 divided by 80 is 9/10 or 0.9. So let's come on back over here. Now we know m, 0.9x plus 8. So now we've got 8 for our y-intercept, 0.9 for our slope, and this is our equation. Y equals 0.9x plus 8. What's the point of generating an equation? Well, if we generate an equation, we can use the equation to make predictions. And I'm going to show you how to do that in C. But before we do that, use the graph to estimate the exam mark of a student with a pre-exam mark of 80. Well, if we do 80 and we trace up, we hit right here. It's a coincidence that we hit 80 because we decided that 80 was 80. So approximately 80% exam mark. And that's an example of interpolation. Didn't ask that, but it's important to note that. We made a prediction between dots. It wasn't past the person that got 95, it was between some dots. So that was interpolation. Last thing we're going to do is we're going to use our equation to make a prediction for an exam mark of a student that got a term mark of 10. Our equation was y equals 0.9x plus 8. Term mark of 10% is saying that x is 10. Because remember, term mark is our x. So we use our equation. 0.9 times 10 plus 8. That's how our equation works. Slope times x plus b. 0.9 times 10 is 9. Plus 8 is 17. So we would say, therefore, their exam mark would be approximately 17%. Now, your equation is going to depend on how you draw your line. If you're doing this question, it might not be exactly 8 when you look at your y-intercept, and it might not have the same run and the same rise, but they're going to be close. I bet you your y-intercept somewhere between 15 and -5. It'll land somewhere in there. And your slope will be somewhere around 0.9. It might be higher like 0.95, it might be lower like 0.85, but it's going to be somewhere in that range. And it's still going to make a similar prediction. If you were outside that range, maybe your line of best fit wasn't so great. But I'm going to rely on your line when you come up with your equation. I don't need you to come up with the exact same equation that I came up with. At the end here it says, deciding if a correlation is linear. So not all relationships are going to be linear, and we're going to learn about some nonlinear models in the next unit. A linear model might not be good if there's not enough pieces of data. That's reason 1. Reason 2, reason 3, reason 4. These reasons might come in handy when you're doing your analysis of your data project at the end of this unit. So let's hang on to this part. This is pretty important. The range of data is too narrow. There does not appear to be a correlation, and there are outliers. So if any of these things happen and you don't get a strong relationship, this is probably why. You didn't collect enough data, or you got low correlation because it's weak or no correlation, or there's outliers. There's a lot of points that are really far from the line. That's why you might not get a strong linear relationship. All right, that's it for 4.3. Lesson 4.5, our next lesson, is done on the computer, and it's an investigation lesson, and our project, and that will kind of cap off the unit here. So thanks for watching, and I'll see you next time.